Hello, my name is Shashank, and we are doing a crash course of 45 days on the course of chemistry. So we are covering the JEE whole syllabus in 45 days. So today I will be doing the first chapter, that is the some basic concepts of chemistry. Okay. So this chapter mainly consists of the mole concept, the reaction solution, the limiting reagents, stoichiometric calculation, and many more important topics that will lay the foundation of the upcoming topic. Yes, this chapter is important for all of the chapters like equilibrium, whether it is thermodynamics or it is thermochemistry. It will help in all of those lectures. So I will start with the laws of chemical combination. Okay, so this topic is although not very popular and not a question is not asked often from this lecture, but these are very basic laws. So these are the primitive laws that were first found and the chemistry foundation in laid on it. So we will deal with each of this law one by one. I will go quickly through these laws, so we will not give much time to this law. The first one is laws of conservation of mass. Second one is laws of definite proportion, laws of multiple proportion, Gay-Lussac's law of gaseous volume, and Avogadro's law. The first one is laws of conservation of mass. So you have studied this law in the physics also. It says that matter cannot be created, neither be destroyed. So if you take a reaction and suppose we have a reaction that is occurring, A is reacting with B, and the product C is formed. So 1 gram, suppose we are taking 1 gram of A, 1 gram of B, and one. So the reactant which will be formed, it will be having 2 gram of C. So you can see here that the weight of the reactants, that is the total weight of the reactant, is 1 plus 1, which is 2, and this is also 2. So I mean that the mass is not destroyed during this reaction, or not it is created. It remains same throughout the reaction. The next law is law of definite proportion. So if you take water or any other compound, then the element which are present in it, they are present in definite ratio. So if you take, it does not matter what is the source of that compound. So suppose if you are taking water of a different place, suppose I am taking water from a place I am taking in Mumbai, then I am taking water from there, then its formula will be H2O. So now next, suppose I take water from Delhi. Here also the formula will be H2O, or whether it is USA. So I mean hereby that it does not depend from where I am taking the water. Its formula is always H2O. Means the ratio of the hydrogen atom and the oxygen atom remains same throughout the space. Now the next law is law of multiple proportion. So what does this law says? So it is often seen that two reactants can combine to form two different products. Then this law says that suppose we are taking the reaction here, so we are forming water by reacting 1 mole of hydrogen or 1 unit of hydrogen for now, and half unit of oxygen to give 1 unit of water. Now we have another reaction in which we are having 1 unit of hydrogen and 1 unit of oxygen to give 1 unit of H2O2. So if you see the ratio here, so if you take the ratio here, that 1 by 2 by 1, then it is 1 is to 2. So I mean here that this ratio is always a whole number, so it cannot be fraction. So this law states that if two elements can combine to form two different compounds, then the ratio by which the reactant will combine it always a whole number. The next law is Gay-Lussac's law. So this law is basically for the reactant in which the reactants are in gaseous state. So suppose we have we have a reaction forming water. So we are taking here the example of water formation in which we are taking 100 ml of hydrogen, 100 ml of hydrogen, and 50 ml of oxygen. So you can see here this ratio here is 100 by 50, means the gases combine in a ratio that is a whole number. So it will be 2 is to 1. So this is the Gay-Lussac's law. The next law is Avogadro's law. This law is somewhat more important than the other laws, so it will be also used later. So what does this law says? It says that if we are taking two volumes, suppose we are taking two volumes of two different gases. Suppose this is the first gas, we call it as A. This is the second gas, we call it as B. Now we are taking the volume as VA here, VA here, and for this we are taking the volume as VB. And also the pressure and temperature is constant for both of this. So this should be kept in mind that pressure and temperature is constant for both of them. Means at the pressure at which gas is kept, the same pressure is maintained here, and same goes for the temperature. And if this volume VA is equals to volume of VB, that is VA is equals to VB is equals to VB, then we can say that Na is equals to Nb, where N represent the number of molecules of A and Nb represent the number of molecules of B. So this implies that. So we can put an implies sign here. So if this thing is true at a given pressure and temperature, then this thing will be automatically true. So this is the Avogadro's law. Now next, we will move to Dalton's atomic theory. So this is the first atomic theory given by any of the scientists. So it is called as Dalton's atomic theory. So it has some key points. We will go through all of this quickly. The first one says that matter is composed of indivisible atoms. So if you take a volume of gas, suppose we are taking a volume of gas here. Suppose this is the volume of gas we are taking. Then it will be composed of atoms. Suppose these are the atoms. So Dalton's atomic theory tells that these atoms are not divisible, means they cannot be broken further. So this was the Dalton atomic theory first point. The second point says that atoms of the same elements are identical. Means suppose these atoms are named as 1, 2, 3, 4, and so on. So suppose this is 1, this is 2, this is 3. So Dalton's atomic theory says that molecule 1 is identical to molecule 2 is identical to molecule 3 and so on. So this is the second point. Now this is third point. So it says that whenever compound is formed, then the elements which combine to form the compound, they are in a fixed ratio. So we will take again the example of formation of water. So the reaction equation is like this: H2 plus half O2 H2O. So this ratio which we are taking, that is 1 is to 1 by 2, this ratio is always fixed. For if we are forming water, in any case this ratio will be always 1 is to 1 by 2 or 2 is to 1. So this is the third point. And now moving to the fourth point. So suppose we are doing a reaction here. So we are taking H2, we are taking O2, then we are reacting it to form water. Now in during this reaction, the reorganization of atoms take place, that is they collide with each other, and if the activation energy or that is accurate and the orientation is perfect, then the reaction takes place, and due to this reorganization, water molecule is formed. So these are the four key points of Dalton atomic theory. Now we will move to some important topics, that is atomic and molecular masses. The first one is atomic masses. So this atomic mass was introduced to measure the amount of substance that is present in a more standard way. So earlier, first of all, that hydrogen was taken as the standard thing, then it was changed to oxygen, and at last it was kept to carbon. So in the recent SI units, this 1/12 of a carbon 12 atom. So to related to that, we take the mass of an element. So suppose we measure the mass of an element, mass of an atom. Suppose we are have to find the atomic mass of A. So we will measure the mass of that atom A. Suppose it comes out to be Ma. So this thing I am giving it, it is not important, it is just for derivation, but if you will learn it, then it will keep a grasp of the upcoming questions. And then what is the second thing? 1/12 of a mass of a carbon 12 atom. So its mass is this 1.9 into 10 to the power minus 26 kg. Okay, so the atomic mass will be relative to this. Suppose it comes out to be mc. So atomic mass will be ma into mc. So it is calculated in this way. Now this quantity, which is 1/12 of the mass of carbon 12 atom, it is called as atomic mass unit or AMU. Later it was defined and it was named as U, which is pronounced as unified mass. Okay, now next slide. Now you have heard the term this thing isotope. So what is isotope? So if you take hydrogen atom for example, there are three isotopes present in nature. The first one is this one 1H, the second one is 2H, and the third one is 3H. This all have the same atomic number. Now only the mass number is varying because the number of proton is same but the number of neutron is not same for all of these. Due to this reason they have the same mass atomic number but different mass number. But during our calculation in laboratories we need the accurate mass. For that reason, to avoid the confusion that whether we have to take this much of what amount, this much of what amount is present in a given sample, we take the average thing so that our calculation become much more easier and we can avoid the confusion between the different standards. How it is calculated? It is very simple. So each isotope is present in nature in a certain percentage. We take that percentage. First of all, we convert it into fraction. So suppose 60% of hydrogen is 1H. Then we take the fraction as 60 by 100 just. This is the ratio. This is the fractional abundance of any 1H. Similarly, next if you want to calculate the average atomic mass of this hydrogen, so I am taking the example of hydrogen only here. 3 are present, 1H, 2H and 3H. So 3 of these isotopes are present. Suppose their relative abundance is, fractional relative abundance is A1, A2 and A3. And these are their mass number, that is A1, A2 and A3. So to calculate this thing, we have this formula, that is summation of AI, where I goes from first isotope to all the isotopes that are present in nature. So we will first multiply this at A1 into A1, now A2 into A2 and A3 into A3. Then we will simply add this to get our average atomic mass. So let me make one thing clear here, that the atomic mass which we consider in our daily life calculation, they are generally average atomic mass. So we are always taking average atomic mass rather than the absolute one. So whether it is chlorine or whether it is carbon or hydrogen, we are taking the average atomic mass. So from now on, whenever I say atomic mass, you can consider as average atomic mass also. Note here, one thing, one terminology is written here. Then when this atomic mass is represented in terms of gram, then it is called gram atomic mass. How? Suppose the atomic mass of oxygen is 16U. Now if we represent this 16U in terms of gram like this, then it will be called as gram atomic mass. And if we represent it in terms of U or unified mass, then it is called as atomic mass. So this is the main difference between these. Their absolute value is different, just the way of representing this thing or means the unit is different. Now next, molecular mass. So what is molecular mass? So suppose a given compound, you have a given compound that is carbon dioxide. Suppose we are taking the example of carbon dioxide and we are said that okay, calculate its molar mass, molecular mass. So how will calculate the molecular mass? So we will first calculate the atomic mass of each of this. So we know by reference that carbon has an atomic mass of 12U and oxygen has an atomic mass of 16U. So for carbon, we have one carbon present in this compound. So we will multiply this 12 by 1. That will be 12U. For oxygen, there are two oxygen atoms present. That is 16 multiplied by 2 and it will be 32U. So the overall mass, molecular mass of CO2 will be simply the addition of these two. That is 12 plus 32, which is 44 U. So you can look at this formula also. So it is simple. So this Xi represents the number of atoms, the elements that are present. So for oxygen it is 2 and for carbon it is 1. And Ai represent the atomic mass. So it is 12 for carbon and 16 for oxygen. Then we multiply it and add it to get our answer. Now, if we go to the definition part, it is same as the atomic mass. Only the difference here is that we take molecule instead of atoms. Means we are calculating the mass of a molecule related to 1/12 of the mass of a carbon 12 atom. Where in case of atomic mass, we were calculating the mass of an atom related to the mass of 1/12 of the mass of a carbon 12 atom. Okay, so this was the point. Now next we will move to vapor density. So this vapor density thing is mainly meant for gases because gases are present in nature as mostly as means if you want to calculate the concentration then it becomes difficult. So generally you refer to the density thing. So how do we calculate the vapor density? So it has a simple formula. If you know the molecular mass of that gas, then you divide it by 2 and you will get your vapor density. There is one another unpopular formula, most of the students are unaware about it. That is the density of gas divided by hydrogen. So if you know the density of that gas and if you divide it by the density of hydrogen, then you can also calculate the vapor density. So suppose you have given the molecular mass of a gas, say that like carbon dioxide gas, and you are told to calculate the vapor density of this CO2. So how it will be calculated? So we have already calculated the molecular mass, so it is 44. So we will divide it by 2. So it will be 22. So this is the vapor density. So in this way we can calculate the vapor density of different gases. Note here another terminology that when this molecular mass is replaced, means the unit is replaced, unified mass is replaced by gram, then it is called it as gram molecular mass. Here another concept comes out, that is formula mass. So this formula mass and molecular mass are same, means they are calculated in the same way. Only the technicality is different, that in molecular mass we have to calculate it for molecule, whereas in formula mass it is calculated for ions. So if the element that is the compound that we are considering is present in the form of ion, then we will take the formula mass rather than molecular mass. So for this we take the example of sodium chloride salt. So we know very well that it is present in the form of ion, that is Na plus and Cl minus, and it has a 3D structure. Now if we calculate the mass, means overall mass, then we call it as formula mass for this structures crystal. So formula mass, now the thing important is here is that they are calculated in the same way. There is no difference in the way of calculation. So it will be simply 23, that is the atomic mass of sodium, plus Cl minus as a atomic mass of 35.5. So it will be 58.5 U. So they are both at the same unit. Now we will move to the most important concept of this chapter, that is the mole concept. So you should be clear about this mole concept because it will be helpful in your thermochemistry, ionic equilibrium, and in your thermochemistry, and then in your chemical equilibrium also. So it is the most important concept of this chapter. So this mole concept is nothing but it is the way of counting entities, elementary entities in SI unit in science. So it is the SI unit in science to calculate the number of things, and it is represented by the symbol mole. And so what is 1 mole? So 1 mole we can say it as 6.022140076 into 10 to the power elementary entity. So in this entity, this much number of entity is called as 1 mole. This thing is called as Avogadro constant, and it is also represented by Na. Now it has a unit of unit per mole. So this mole has a unit of unit per mole. So what does this unit says here? So this is the very crucial concept that children often get confused with. They do not know that whether this mole is for atoms or it is for molecules or it is for electrons, protons. So let me make one thing clear here, that mole is not specified to a certain object, or it is not related to a certain thing, it can be anything. So it can be 1 mole of molecule, it can be 1 mole of electron, or it can be 1 mole of atom or ion. So it is not dependent on the elementary entities we are taking, but 1 mole is same for all of them. It will always contain 6.022 into 10 to the power 23 molecules or electrons or atoms or ions. So if you want to consider from a daily life application, so you have heard the term dozen. So if you are telling dozen, then it does mean that it will contain 12 entities. It does not depend upon whether we are taking apple or banana. I mean, in daily life we take the banana 1 dozen, but if we are saying that we have 1 dozen of apple, then it will be always 12 apple, or we are taking 1 dozen of oranges, then it will be 12 oranges. So it will not depend on the thing of which we are taking, it will be always 12. So similarly, similar to that concept, we have 1 mole. So 1 mole will be 6.022 into 10 to the power 23, no matter what elementary entity we are taking. Okay, now we will move to another concept, which is the most important concept related to mole concept, that is molar mass. So what is molar mass? So for any compound, say we have this compound as methane, that is CH4. Now, if we count the number of molecule at 6.022 into 10 to the power 23, here you can see that I am dropping off the other digit, so you can drop off it. It is not important to take all the digits after decimal. You can take up to 3 digits, or if it is mentioned in the question, the value is given in your question, you can take that value. So it will be 6.022 into 10 to the power 23 molecules of methane we are taking, and the amount of substance or the gram of substance which contains this much amount of molecules will be called as molar mass. So suppose we are having 1 mole of CH4, 1 mole of CH4, then the mass of this 1 mole of CH4 will be called its molar mass. How it is calculated? So this thing here, it is very unique, means it is very simple. So you can calculate the molar mass in a very simple fashion, like the molecular mass, like the formula mass. It is calculated in the same way. There is no difference in the method of calculation. We will calculate in the same way, whether it is means this thing is for same for all these three: molecular mass, formula mass, and molar mass. Only the unit and the technicalities will change. So if we are defining molecular mass, so we are saying that 1 by 12th of carbon 12 atom. So we are taking the mass of that atom relative to that. But when we are saying molar mass, then we are taking that amount of substance which will contain Na elementary entities or Na molecules. Now this formula will be used everywhere. So it is used for calculation of number of moles. So suppose we are given some mass and we are told to calculate the number of moles, then we will simply divide it by molar mass to get our answer. So if you want a simple illustration of it, I can take an example and solve it. So let me take a question here. Suppose we are given that we have 32 gram of 64 gram of oxygen molecule or oxygen gas, 64 gram of oxygen gas, and we are told to calculate the number of moles. So first we will calculate the molar mass of this oxygen. So I will calculate it in the same way as the molecular mass is calculated. So you know the way. So the molar mass is, so 2 oxygen are present. So 2 multiplied by the atomic mass of oxygen is 16. So 16 to the 32. So it will be 32 gram. Yes, this thing here, it has a unit of gram. You must keep in mind always that it has a unit of mass. Now number of moles is equals to, so the given mass is 64 gram divided 32, that is 2 to the 4, 2 3 the 6, that is 2 moles. of oxygen is present. So in this way, you can calculate the number of moles easily for any given amount. Now we'll move to next one of the question that we have put up here to get to grasp the concept which we have seen in the mole concept. So this is the question. It says that which of these species has the largest number of atoms that is present. Means if you have to calculate the number of atoms for each of this. So let me calculate. So if you have to know the number of atoms, then you can simply know it by calculating the molar mass. Sorry, the number of moles, and that much times will into Na will be the number of molecules or atoms. So for 127 gram of iodine, if you calculate the number of moles, we know the formula as. So for first option, I am calculating. Now number of moles of iodine is equals to given mass. So the mass given is 127, and I know if you can refer to any periodic table. You know will get the answer of this atomic mass of iodine. So it is 127 gram molar mass. So it is the molar mass of this. So it will be 1 mole. So what does 1 mole means? So we have Na number of iodine atoms. Next we have 48 gram of magnesium. So number of moles of magnesium will be 48 gram. The atomic mass for magnesium is 24. So it will be 2 mole. That is 2 into Na number of magnesium atoms. Next is 71 gram of chlorine. So 71 gram of chlorine. So we will calculate the number of moles for chlorine also. Number of moles of chlorine. So chlorine has atomic mass of 35.5. So it will be simply 2 moles. That is 2 into Na number of chlorine atoms. The last example is 4 gram of hydrogen. The last option is 4 gram of hydrogen. So number of moles of hydrogen is equals to given mass is 4, and the molar mass or the atomic mass of hydrogen is atomic mass of hydrogen is 4. So we will calculate like this. So number of moles of hydrogen is 4.0 gram divided by